We all know about microplastics, right? Those tiny bits of plastic that just seem to be everywhere, from the ocean to, well, even our own bodies.
Yeah, it's pretty unsettling. We think of them as this environmental pollutant, but new research from Boston University is suggesting that the bigger danger of microplastics might be what they're doing inside us, making us sicker.
Okay, let's dive in. First, for anyone who needs a quick reminder, when we talk about microplastics, what are we actually talking about?
Essentially, think of any tiny piece of plastic less than 5 millimeters long. It could come from the breakdown of bigger plastic stuff, like when that plastic water bottle gets crushed in the landfill. But it can also come from fibers shed from clothes, or even those little microbeads that they used to put in face washes.
And these things are everywhere, right? Yeah, we've done other deep dives into this, and it's not a pretty picture.
It really isn't. They're in our food chains, deep in the ocean, in the air we breathe, even inside us. And this new research, published in Applied and Environmental Microbiology just last week, has uncovered a connection between microplastics and antibiotic resistance. And this is what we are diving into today, this hidden global threat.
So, what did the researchers at BU find?
Okay, the core finding is that bacteria that are exposed to microplastics, they develop a much stronger defense against antibiotics. The surprising thing is that it's not just that the plastic is there. It seems like it's actively helping the bacteria become more resistant.
So it's not like the plastic is just hanging out, and the bacteria are too, and they're like, hey, let's team up. The plastic is actually doing something.
Exactly. And to understand that, we need to talk about biofilms.
Okay, remind me what a biofilm is again.
So you've got these bacteria, and when they find a surface they like say a microplastic particle, they attach to it and start to form this sticky substance, this film, basically.
It's like they're building themselves a little house.
Yeah, and that's the biofilm, and it acts like a shield protecting the bacteria from threats in their environment, like from antibiotics.
Makes sense. And what's the connection to microplastics specifically?
Well, Neela Gross, she's the PhD candidate who led the study, she found that the biofilms that form on microplastics are much tougher and thicker than biofilms that grow on other surfaces, like glass.
Oh, wow.
Yeah, she actually compared it to a house with a ton of insulation. It makes it much, much harder for antibiotics to get through and kill the bacteria.
So it's like they built a super fortress out of this plastic, and they tested this with different types of antibiotics and different plastics, right?
Yeah, they did. And what's really striking is that no matter what antibiotic they used or what kind of plastic it was, the rate of antibiotic resistance on the microplastics was consistently really high. Seems like this is a pretty universal effect.
That is kind of terrifying.
Yeah.
And Professor Mohammed Zaman, he's a professor of biomedical engineering at BU and one of the senior researchers on this study. He's suggesting that microplastics are playing a more active role in this whole process than just being a surface for these super biofilms.
Yeah, he really emphasized that. It's not just that the microplastics are providing a place for the bacteria to grow. They're actually contributing to the development of these resistant organisms.
Okay, so they're not just an innocent bystander. This is really bad news for everyone. But the research calls out refugee communities as being especially vulnerable. Why is that?
Well, think about it. Refugee communities often have a lot of plastic waste because of limited waste management systems, and they might not have the best sanitation infrastructure.
Right, so you've got a lot more microplastics around, and then you've got conditions that make it easier for infections to spread in the first place.
Exactly. It's kind of a double whammy. And Professor Zaman has actually done a lot of research at BU's Center on Forced Displacement, and he's found that refugees are already at a higher risk for drug-resistant infections. And this new finding about microplastics, well, he said, and I quote, "There is certainly a concern that this could present a higher risk in communities that are disadvantaged and only underscores the need for more vigilance and a deeper insight into microplastic and bacterial interactions."
And the number of people we're talking about is huge. The study mentions that there are something like 122 million displaced people around the world as of last year.
Yeah, that's a lot of people potentially facing this increased risk. It's definitely something to be concerned about. So let's dig a bit deeper into what makes these biofilms on microplastics so good at promoting antibiotic resistance. Neela Gross, the lead author on the study, she has some interesting ideas about why this is happening.
I'm all ears.
One theory is that it might have to do with the way plastic is structured at a molecular level. See, a lot of plastics are hydrophobic.
Hydrophobic meaning?
Meaning they repel water, they don't like water. And it might be this water-repelling property that makes it easier for the bacteria to attach to the plastic in the first place.
So kind of like oil and water, they don't mix.
Yeah.
The bacteria might be more likely to stick to a surface that isn't water-friendly.
That's the idea. Another possibility is that the microplastics might actually be absorbing the antibiotics from the surrounding environment. So the antibiotics get soaked up by the plastic and they can't get to the bacteria inside the biofilm.
So the plastic is acting like a shield in a way, and a sponge.
Right. But perhaps the most worrying finding of all is that even after they removed the microplastics, the bacteria that had been growing on them, they were still able to form these stronger, tougher biofilms.
Oh, so even a short exposure to microplastics can have a lasting effect.
It seems so, and this is just, one piece of a much bigger puzzle. We've got this huge global antibiotic resistance problem. The study mentions that there are almost 5 million deaths every year linked to drug-resistant infections.
And we tend to think of that as being caused by overusing antibiotics, like when doctors prescribe them too often or when they're used in agriculture.
Yeah, and that's definitely part of it. But this study really highlights how important the bacteria's environment is, that microenvironment, in driving this resistance. It's not just how we use antibiotics, it's also about the world that we are creating around these bacteria.
So it's a much more complex issue than we might realize, and Professor Zaman is urging more scientists to focus on this, right?
Absolutely. He's saying that, we talk about the political and social and economic aspects of things like antibiotic resistance and the health of refugees, but we often forget about the basic science, like how microplastics and bacteria are interacting at a fundamental level.
Right, so we need to understand the basic science before we can even begin to address the bigger problems. So if there's one big takeaway for our listeners from this deep dive, what would it be?
I think the big takeaway is that we need to think about microplastics as more than just an environmental pollutant. This research really shows how they could be a major factor in the rise of antibiotic-resistant bacteria, maybe even more important than we thought before.
And it's hitting already vulnerable populations, like refugees, even harder.
That's right. And it really just highlights how closely our own health is tied to the health of the environment.
Absolutely. So, for our listeners, as you go about your day, think about all the plastic around you, and consider this. If something as seemingly harmless as a tiny piece of plastic can have these kinds of effects on bacteria, what other hidden impacts might our reliance on plastic be having on our health and the health of the planet? What other seemingly inert materials in our environment might be having these unexpected biological effects? It really makes you think about the interconnectedness of it all, and the unintended consequences.
Yeah, food for thought, for sure.
Absolutely.